students, I am Dilip Udani, Assistant Professor at LJ Institute of Engineering and Technology. Today in multiple integrals, I will teach you a new topic, that is change of variables in double integrals by Jacobians. So let's start. So here is the topic, change of variables in double integrals by Jacobians. In some cases, evaluation of double integral becomes easier by changing the variables. Let the variables x, y are replaced by new variables u, v by the transformation x equals to f1 of u, v, y is f2 of u, v, then double integration function of x, y dx dy, that is equals to double integration f of f1, f2 modulus of j du dv. Now say this is result number 1, where Jacobian j, that is equals to del of xy with respect to del of uv, and this is equals to determinant of del x by del u, del x by del v, and in the second row del y by del u, del y by del v. This is how we define Jacobian of j, which is del of xy with respect to del of uv. Using equation 1, the double integral can be transformed to new variables. Now we have one example related to this topic. Example number 1, evaluate integration from 0 to 4, integration from y by 2 to y by 2 plus 1, 2x minus y by 2 dx dy by applying the transformation u equals to 2x minus y by 2, v equals to y by 2, and draw both regions. So here is the solution. Here x varies from y by 2 to y by 2 plus 1. Now x equals to y by 2. So we have 2x minus y equals to 0. And from this equation x equals to y by 2 plus 1, we have 2x minus y equals to 2. Now you can see that 2x minus y upon 2, that is equals to u. So 2x minus y, that will be 2u. So replacing 2x minus y by 2u, so we have 2u equals to 0. And again replacing 2x minus y by 2u, so we have 2u equals to 2. And this is the reason u equals to 2x minus y by 2. So 2u equals to 0, therefore we have u equals to 0, and 2u equals to 2, so we have u equals to 1. Therefore u varies from u equals to 0 to u equals to 1. Here y varies from 0 to 4, this is y, right? It will vary from 0 to 4. V equals to y by 2, therefore y equals to 2v. So replacing y by 2v, we have 2v equals to 0. Again replacing y by 2v, so we have 2v equals to 4. So 2v equals to 0, then v equals to 0 by 2, which is 0. 2v equals to 4, so v equals to 4 by 2, which is 2. Therefore v varies from v equals to 0 to v equals to 2. So we have limits of u and v. U will vary from 0 to 1 and v will vary from 0 to 2. Now this is the graph. This is the graph in xy plane and this is the graph in uv plane. This is the graph of the line y equals to 2x. This is the graph of the line y equals to 2x minus 2. Y equals to 0 line, that is nothing but x-axis, and y equals to 4 line, that is nothing but a line parallel to x-axis and perpendicular to y-axis. And this is the region of integration bounded by these four lines in xy plane. Now we are going to transform this region which is in xy plane to a uv plane. This is u-axis and this is v-axis. So this is going to be a line u equals to 0, this is u equals to 1, this line is v equals to 0 and this line is v equals to 2. So this is the required region of integration in uv plane. So we have transformed xy plane to uv plane. Here u equals to 2x minus y by 2 and v equals to y by 2. Now we have to find out Jacobian of j. To find out Jacobian of j, we require x in terms of uv and y in terms of uv. But here we have given u as a function of x and y and v as a function of x and y. So instead of finding j, we will find out j dash. And j dash, that is equals to del of uv with respect to del of xy. And this is equals to del u by del x, del u by del y in the first row, and in the second row we have del v by del x and del v by del y. Now del u by del x, that is partial derivative of u with respect to x, keeping y constant. So derivative of 2x is 2, y is 0 and 2 by 2, that is 1. Now del u by del y, that is partial derivative of u with respect to y, keeping x constant. Derivative of 2x is 0 minus derivative of y is 1 and 1 divided by 2, it is minus 1 by 2. Now del v by del x, that is partial derivative of e with respect to x, keeping y constant. So y by 2 is a constant, so its derivative will be 0. Then after del v by del y, that is partial derivative of v with respect to y, right? So keeping x constant and derivative of y with respect to y is 1, so del v by del y, that is 1 by 2. Now we will solve this determinant. 1 into 1 by 2, that is 1 by 2, minus 0 into minus 1 by 2, that is 0. So the result is 1 by 2 minus 0, which is 1 by 2. Now this is the value of j dash, that is equals to 1 by 2. We have one important property, by properties of Jacobian. J into j dash, that is equals to 1. And here we are interested in finding out j. And already we have gone through j dash, which is 1 by 2. Therefore j equals to 1 upon j dash and inverse of j dash, which is 1 upon 2, that is 2. So the value of j is 2. Now dx dy, that is equals to modulus of j du dv, and modulus of j, that will be 2, and du dv will be as it is. Hence the new form of the integral is I, that is equals to integration from 0 to 4, integration from y by 2 to y by 2 plus 1, 2x minus y by 2 dx dy. This is the given integration and this is in xy plane. Now we have changed this multiple or double integration to uv plane. So this is equals to integration from v equals to 0 to v equals to 2, integration from u equals to 0 to u equals to 1, and 2x minus y, that is equals to 2u divided by 2, so 2 will cancel out, and over here we will be having modulus of j, that is 2, so the result is 2u du dv. Now we will find out this double integration. So integration from 0 to 2 will be as it is. Now integration of u with respect to u, that is u square by 2, so 2 will cancel out and it is u square and limit is from 0 to 1, dv will be as it is. Now integration from 0 to 2, for upper limit it is 1 square, minus lower limit it is 0 square, so the result is 1, and this is equals to integration from 0 to 2 dv. Now integration of 1 with respect to v, that is v, and the limit is from 0 to 2. So for upper limit 2 it will be 2, and for lower limit 0 it will be 0. So the result is 2 minus 0, which is 2. So this is the required answer. Now we will see example number 2 related to this topic. Evaluate double integration of x square plus y square dA over a given region R by changing the variables, where R is the region lying in the first quadrant and bounded by the hyperbolas x square minus y square equals to 1, x square minus y square equals to 9, xy equals to 2, and xy equals to 4. So here is the solution. Let u equals to x square minus y square and v equals to xy. So first of all we will find out j dash, that is equals to del of uv with respect to xy, and this is equals to del u by del x, del u by del y in first row, and then after del v by del x and del v by del y in the second row. Now first of all, del u by del x, that is partial derivative of u with respect to x keeping y constant. So derivative of x square is 2x and y square is 0. Then after del u by del y, partial derivative of u with respect to y keeping x square constant, so its derivative will be 0. Then after minus y square, so its derivative will be minus 2y. Then after del v by del x, partial derivative of v with respect to x keeping y constant, and derivative of x is 1, so 1 into y, result is y. And finally del v by del y, that is partial derivative of v with respect to y keeping x constant, so x will be as it is, and derivative of y is 1, and 1 into x, that is x. Now we will solve this determinant. 2x into x, that is 2x square, then after minus y into minus 2y, that is plus 2y square. Now taking 2 common, so into bracket we have x square plus y square. Now our properties of Jacobian, j into j dash equals to 1. Therefore j equals to 1 upon j dash, and that is equals to 1 upon j dash is 2 into bracket x square plus y square. Therefore dx dy, that is equals to modulus of j du dv, and this is equals to modulus of j is 1 upon 2 into bracket x square plus y square du dv. The region in the xy plane bounded by the curves x square minus y square equals to 1, x square minus y square equals to 9, xy equals to 2, and xy equals to 4 is transformed to a square in the UV plane bounded by the lines u equals to 1, because x square minus y square is u. So it will become u equals to 1, and for this one it will become u equals to 9, and xy equals to v. So for this one we have v equals to 2, and finally for this one we have v equals to 4. So in the UV plane we will be having these 4 lines vary from u equals to 1 to u equals to 9, and v will vary from v equals to 2 to v equals to 4. Now this is the given region of integration in xy plane. This is the graph of x square minus y square equals to 1. This is the graph of x square minus y square equals to 9. This is the graph of xy equals to 2, and this is the graph of xy equals to 4. So this is the required region of integration in xy plane, and the required region of integration in UV plane, that will be formed by these 4 lines, that is u equals to 1. So this is a line u equals to 1, then after to u equals to 9, this is a line u equals to 9, then after v equals to 2 to v equals to 4, this is a line v equals to 2, and this is a line v equals to 4. So the required region of integration in the UV plane, that is this rectangle formed by the 4 lines u equals to 1 to u equals to 9, v equals to 2 to v equals to 4. Hence the new form of the integral is I, that is equals to double integration of x square plus y square dx dy over a given region R, that is equals to double integration of x square plus y square and dx dy, that is nothing but modulus of j du dv, and this is the value of modulus of j, that is 1 upon 2 into bracket x square plus y square. Now x square plus y square, x square plus y square will cancel out, 1 upon 2 will be as it is, and integration from v equals to 2 to 4 and integration from u equals to 1 to 9 du dv. Now this is equals to integration of 1 with respect to v, that is v, and the limit of v is from 2 to 4, and integration of 1 with respect to u, that is u, and the limit of u is from 1 to 9. Now we will simplify this result. This is equals to, for upper limit 4 it is 4 minus, for lower limit 2 it is 2, so it is 4 minus 2, multiplied by, for upper limit 9 it is 9, for lower limit 1 it is 1, so it is 9 minus 1. Now we will simplify this result. So 4 minus 2 is 2, 9 minus 1 is 8, this half will be as it is, so 2 will cancel out and the result is 8. So in today's lecture we have seen how to find out double integration by changing the variables in xy to uv with the help of Jacobian. And we have seen 2 examples related to this topic. Thank you for watching this video. I will see you in the next lecture.